Okay, the next question, or one that's similar to it, can be expected on a future exam, not on one that's going to be too recent, right? The next question is going to have three letters in it, namely A, B, and C. And while we don't know the values of these numbers, somebody else does. So whenever we see these letters, we're just going to do the same things that we would have if we had actually known the numbers. So, for example, if we needed to start with the number 10 and divide by 2, we're often just in the habit of writing the number 5 right away. And that's fine, because we know that 10 divided by 2 is 5. But we also could have just written 10 over 2, right? Just as a fraction. Just 10 divided by 2 and not simplify. If we needed to start with a cubed b to the fifth and divide by 2, we'll just write a cubed b to the fifth over 2. And then that fraction just won't simplify any further. So in the problem we're about to look at, we won't have a cubed b to the fifth or a cubed b to the fifth over 2. But I just wanted to make a point, I guess, to say that it's important to try to think of 10 over 2 and a to the third b to the fifth over 2 as applying the same general process. It's just namely taking something and dividing by 2. So don't worry about this a cubed b to the fifth. I was just making up a silly example for a second. We will end up in the process we're looking at using both of the formulas from the warm-up, which are still shown in the upper right corner of the slide. So here's what we're going to do. Let's solve for x in ax squared plus bx plus c equals 0. So somebody knows what number a, b, and c are. We don't know what numbers, but a, b, and c are just some numbers. So there's this number c on the left side that's getting in the way. Visually, we've seen that issue, so there's a plus c, so let's subtract c on both sides. You get ax squared plus bx equals negative c. Now, note that there is a number in front of x squared, which we don't know to be 1 or not. There's an a there. We've got a coefficient of a. The coefficient of x squared is a instead of 1. So let's divide both sides by a, and it's going to look like this, right? So the entire left side, ax squared plus bx, divided by a, equals on the right side negative c over a. Now we can't cancel the a's on the left side, right? Because they're not factors because of the plus sign. So we're going to split up the left side. Instead of being one fraction, make it two fractions, right? Ax squared over a plus bx over a. So think about, adding fractions with a common denominator. And the whole point now is that the plus sign is not inside the fraction. It's between two separate fractions. And now do the a's on top and bottom cancel? Well, yes, they do, right? So ax squared over a, just to break it down a little more, could be thought of as a times x squared over a times 1. And so the a's on top and bottom are factors, and they'll cancel. So then we're left with x squared plus b over a times x equals negative c over a. So one other little change here, other than the canceled a's, is instead of bx over a, we just push that x off to the side. So it's still numerator quantity, right? It's b over a times really x over 1. But we just write it this way because in this format, now that the number hidden in front of x squared is a 1, we can start thinking about the linear coefficient and second stick and all that business. So here the linear coefficient is b over a, right? Remember, the linear coefficient is the thing in front of x, so it doesn't include x. So it's not b over ax. B over ax is where we look, and the linear coefficient is b over a. So then half of that, meaning to divide by 2, is the same as introducing a factor of 2 in the denominator. The second stick is b over 2a. And then the constant that we need to add to both sides is take that second stick, namely b over 2a, wrap it in parentheses, and then square it. Now, how does that work out? Well, that's where a formula from earlier that's highlighted in the upper right in red. We will square the top and square the bottom separately, right? That a to the k over b to the k. And then that can even simplify just further as b squared over 2 squared a squared, or in other words, 4 times a squared. Okay, so at the top of the next slide, let's mention these things. We have the most recent equation here. X squared plus b over a times x equals negative c over a. We're also going to just make a copy of the linear coefficient and the second stick and the constant, though in their most simplified form. So we're not going to bother writing all this stuff. For instance, at the top of the next slide, you'll see just the constant is b squared over 4a squared. So here we go. Okay, we've got x squared plus b over ax equals negative c over a is the equation we've got so far. And then here was the linear coefficient, second stick, and constant. And here's a picture of what we have so far. So what's highlighted in yellow is the left side of the first equation. is x squared plus b over 2ax plus b over 2ax, or in other words, all added together and collected like terms. That is a picture of x squared plus b over ax. But it's missing that lower right corner. That lower right corner, you see the picture in blue, has this additional little piece down here, and that's b over 2a times b over 2a, which is really b squared over 4a squared. So in order to get the picture to be this, we need to add that missing piece, but not just on the left side, we've got to add this on both sides, right? So we're going to add b squared over 4a squared to both sides, and so once we've added this to both sides, the new left side is like what's shown in blue here, right? So we've got x squared plus, x squared plus b over a times x plus the thing we just added, b squared over 4a squared, equals the thing we just added minus the original c over a there. Let's factor the left side. It will, as always, be x plus second stick squared. So the right side, we're going to need a common denominator. So take a look. The b squared over 4a squared minus c over a, just take the c over a fraction and multiply the top and bottom by 4a. So you don't need to do anything to the first fraction. Leave b squared over 4a squared alone. So look, the left side is factored as x plus second stick squared. So x plus b over 2a quantity squared. And the right side, in preparation for simplifying, subtracting the two fractions, we've created a common denominator. So we have b squared over 4a squared minus 4ac over 4a squared. We'll copy that to the top of the next slide. Here it is. Now that the right side is two fractions with the same denominator, and that was a requirement to simplify subtracting. Now let's just create one fraction out of that. So b squared minus 4a squared, b squared minus 4ac, all over 4a squared. Now we still need to solve for x, and look, x is only written in one place, so we need to keep undoing the last thing. So there's a square that we have to undo, so square root both sides. Don't forget that the first step, where the square root symbol appears on both sides, you need a plus or minus sign. On the right side, now we could have simplified the left side, but I just wanted to not have too much happen visually. So on the right side, copy the plus or minus sign, but root the fraction. Instead, it becomes just root the top and bottom separately. That's the formula that's highlighted in the upper right. And then on the left side, we can simplify the square root sign with the square, right? Those will undo each other, so we're just left with x plus b over 2a. On the right side, not much happened other than the radical in the denominator. So root 4a squared, that's all perfect square stuff. So when you root 4, you get 2, and when you root a squared, you get a. So that's why the denominator on the right side just says 2a. Then, one last thing to solve for x, right? We just need to, notice it says x plus b over 2a. We just need to subtract b over 2a on both sides and have x is equal to negative b over 2a plus or minus radical b squared minus 4ac all over 2a. We could leave it like this because technically we've solved for x, but I think it's more typical when you have two fractions with the same denominator to just combine them all into one fraction. So we could write this as x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So what happened here is we started with a very generic situation. We started with, we don't know what number, but let's call it a. We don't know what number, but we'll call it b, and we don't number, but we'll call it c. And we started with ax squared plus bx plus c equals 0. And then we applied this completing the square process, all the same thought processes that we've done with the other problems where we did know the numbers. And this led to x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is known as the quadratic formula.